Thank you all for joining us. Today, we're going to jump into a really exciting education here with Mike Nelson, who is a meteorologist based in Denver. He has a profound dedication to climate education and weather forecasting and decades of experience. He's been a leading figure in educating the public about the realities of weather patterns and the impacts of climate change. His career spans several decades, during which he earned multiple awards for his forecasting accuracy and commitment to science communication. Mike is not only known for his nightly weather reports, but also an active role in his community where he's often spoke about climate change and its effects. Mike is also the author of the world's littlest book on climate, 10 Facts in 10 Minutes About CO2.
Gabriel, thank you so very much for that generous introduction, and good morning, and in some cases to our person joining us from Milan, Italy, good evening. It's very gratifying to see the attendance that we have today. Joan, thank you for all the work in setting this up. We have a climate emergency going on, but it's something that we can still fix, and I think that's very important as we move forward. If at the end of this presentation you wish to get in touch with me with any questions or comments, you see all of my contact information right there. And we spoke about the book. If you want to use that QR code, you can download a copy of the world's littlest book on climate. On the back of the book itself is a QR code. So if you're reading on an airplane and somebody says, "What's that you have?" they can just grab their phone and get their own electronic download. I wrote this book in conjunction with Dr. Peter Tons, who's the world's foremost authority on atmospheric carbon. He ran the lab at Mauna Loa. He's based in Boulder, Colorado, and is a brilliant man. He works for NOAA, the National Oceanic and Atmospheric Administration. And my job as a television meteorologist was to try and take Dr. Tons' brilliance and get it down to an area that average people can understand, because it's not that hard to understand. I also want to give some shout outs to Michael Banks, who is the third member of our team who helped really make this project a reality. I've been a meteorologist on television for almost 50 years. And in general, our role is to explain to our audience in about 2.5 to 3 minutes something complicated, the weather, and make it easy to understand. And it gives us a unique opportunity and I think a responsibility to educate the public with the facts about climate change. Regardless if you're watching this in Italy, the United States, or anywhere in the world, the television weather forecaster's main job is to be the nice, friendly person that people tune in to find out about their weekend plans or their daughter's wedding or whatever. But given the number of people, not just Americans, but sadly, mainly Americans, that are skeptical about climate change, we must communicate the correct science to the public. And our strength is explaining complex concepts in easy understand terms. So why would we shy away from talking about it? Sadly, far too many television weather forecasters do tend to shy away from talking about climate change because it might get uncomfortable from the one or two negative emails that you'll get from somebody saying, "Now you've politicized the weather report." And I'm trying to change that. This is a market exclusive that I do not want to have. So I'm urging my colleagues and my competitors at the other stations to talk more about this, because we already do talk about scientific areas that are not necessarily meteorology. As TV meteorologists, we are asked all the time, "Hey, there's a volcano, or there was an earthquake, or there's a comet or a meteor shower. Can you talk about that and explain it to our viewers?" That's not meteorology, but it certainly is science, and we can learn enough to explain it simply to our audience. Carl Sagan, about 30 years ago, in the book The Pale Blue Dot, talked about the fact that, anyway, the pale blue dot shows us that we're pretty tiny out there, and the things that we are going to do to try and change the future of our planet are very important. Fossil fuel's been a miracle, but let's realize that it's not the future. Life without fossil fuel is cold, dark, and short. Concentrated energy from the sun stored underground millions of years, and the great energy density made it so effective. But the fact of the matter is that lighting fossil carbon on fire is causing the planet to get warmer. We can have a modern society with lower emissions. So when people ask, "Gee whiz, carbon or climate change is so far down the line on things people are concerned about," that's because they're asking the wrong question. If you are worried about the economy or the cost of goods or national security or immigration or the border or the wars in Ukraine or Gaza, you are worried about climate change, because climate change is a threat multiplier for every one of those things. The 7 deadly things on climate change, this is what I've heard of over the years. And these are all things that we can talk about and address. So I hear these all the time. You can't even forecast next week. The climate's always changed. Carbon dioxide is just a trace gas. They said it was cooling in the 70s. It's snowing in name the town, so it can't be getting hotter. It's too expensive to do anything about it, or you cannot trust the media. Climate is easier to forecast than weather. Climate is a long-term average of conditions. Weather is chaotic and changes rapidly. So you'd expect the climate of Miami to be warmer than Denver in February. It's basic thermodynamics. If you add heat to something, it gets warmer. It's why day is warmer than night and summer is warmer than winter. And climate is easier to forecast then because it's just heat balance. Heat in versus heat out. You add heat, it gets warmer. People have said to me, what about the fact that the climate's always changed? We've had ice ages and continental drift and mass extinctions. We know the causes, which are only three: the changes in the orbit, called Milankovitch cycles, the solar output, which we can measure, it's not changing. If anything, it's slightly been cooling, and the atmospheric chemistry. And of that, only one is changing, and changing fast, and that is the chemistry of the atmosphere. Uncharted territory, at least the highest in 800,000 years. We're at 422, how ironic, as of yesterday, 422. And we are adding 100 million tons of carbon every single day. My carbon birth date in 1957, we were at 315. If you want to check your CO2 birthday, you can see the link right there. When I hear that carbon dioxide is just a trace gas, each molecule of CO2 is like a feather in a down comforter, trapping heat in the atmosphere. The same amount of carbon monoxide in our air at over 420 parts per million would render us unconscious. The key takeaway is small amounts do matter. Case in point, the tiny little blood clot that gives you a stroke or a heart attack is tiny, minuscule compared to the size of your body, but highly effective. The size of the COVID virus, minuscule, dramatic in its effect, but small amounts do matter. Back in the 1970s, they said that we were headed for a new ice age. That's Cindy and I in the 1970s, my wife. But even then, there were many more papers that warned of warming as opposed to cooling. We knew it even then. I was in the lectures about that at the University of Wisconsin, and we knew that the overwhelming impact would be on carbon dioxide. You can't trust the scientists or the journalists. We do not see many Jags or Mercedes in the parking lot at NCAR, but I did see this bumper sticker that says Mother Earth bats last and she's warming up. So fossil carbon is being rapidly released into the atmosphere. The carbon deposits of oil and coal and fossil gas that we are burning were deposited in the Earth's sediments over 300 million years, or 3 million centuries. And since the beginning of the Industrial Revolution, we have released that carbon back into the atmosphere in less than 3. It's the rate of change that is the big problem. And that is not shrinking, it's growing. We can identify the fossil carbon isotope. We know it's not from volcanoes. And we know we're adding 100 million tons of CO2 every single day. And the carbon dioxide that is in the atmosphere stays there for centuries. The CO2 from the first Model T car is still in the atmosphere, causing the Earth to warm. It's not new science. In 1825, 200 years ago, Joseph Fourier, a French mathematician, realized the Earth is too far from the sun to be as warm as it is. The warming must be coming from the atmosphere. And in 1863, John Tyndall, an Irish chemist, identified carbon dioxide as the gas that absorbs long wave or earth energy. Svante Arrhenius in 1895, a doubling of global CO2 had warmed the Earth by several degrees, with the warmest being in the northern and southern hemispheres near the poles. All of this has come true. When people say none of those climate predictions have come true, actually almost all have, and if they haven't, it's been because they were too conservative. And in 1856, at a time that women were not scientists, Eunice Foote, an American scientist, placed different jars of gases in the sunlight and measured the temperature, and the CO2 warmed up the most. Now, it's not political. I have met Al Gore, but the fact that I have met Al Gore and had a picture with him is not the reason that I understand the greenhouse effect. Without the greenhouse effect, the Earth would be about 60 degrees colder. So it's a good thing, but it's too much of a good thing. Each doubling of CO2 increases the energy retention of the atmosphere by just under 4 watts per square meter. And that may not be much over 1 square meter, but over the entire Earth, it is a huge amount of energy. It's heat in versus heat out. And the forcing of that doubling is about 5 degrees Fahrenheit. I use Fahrenheit here in America over the entire Earth. The melting of the ice caps and glaciers could cause a rise in sea level of 5 to 10 feet in the next century. We are already seeing the instability of the Thwaites Glacier in Antarctica, along with the massive meltouts of the Alps and the massive melting in Greenland. It's all happening. And what do we know for sure? It's getting hotter. These are measurements. These numbers don't lie. And so we're having the hottest years on record, year after year, somewhat altered by El Nino and La Nina, but basically the trend continues to be up. Very few record lows, many more record highs. Snowpacks are melting out earlier. Drought is not just a lack of rainfall. It's also the increased evaporation due to hotter temperatures. So the same rain does not give you the same result if you have hotter temperatures. The Arctic is warming fast. Our anomalies in temperature since 1984 are greatly showing how much temperatures are warming in the Arctic, just as Arrhenius had mentioned back in the 1890s. We are getting more and more severe floods, fires, droughts. It is causing our climate to be more severe. The droughts are drier, the floods are wetter, the fires are more frequent. And it's not something that's a distant threat anymore. This is from my weathercast on December 30th, 2021, a massive firestorm along the Front Range known as the Marshall Fire. So all of these are connected to what you see every night on the weather report. Fires, shrinking snow and ice, the heat waves, the droughts, the extreme rainfall and flooding, all related to what we expect a warmer world. In Colorado, recent study came out just this spring, the third edition 2023 from the Colorado Climate Center. Average temperatures rising, warmer temperatures, winter, spring, summer, and fall. How will it affect us here? Earlier melting out of snow, lower water levels in our rivers, wildlife, flora, and fauna. Mountains are pointed, and yeah, there's still cooler conditions farther up the mountain, but there's less land up there. And what we find as far as water stresses, flooding will be a bigger threat in the east. Droughts will worsen in the western United States. And our air quality, after decades of progress, is worsening because of the particulates from the increases in wildfires. So despite the fact our skies are bluer most of the time, we still have increasing days with unhealthy air quality. Here in Denver, our climate is moving south without significant cuts. Eastern Colorado could have the climate of northern Mexico by 2100. Amarillo, by the time my grandchildren are in their 40s. Our heat waves are getting hotter. 20 days above 100 degrees in Denver. We used to average maybe 1. Now we're averaging about 3 or 4. 20 days and 40 days above 100 in Denver by 2100. That would mean that at Rocky Mountain National Park, they'd have 100-degree days common in the summertime. But it doesn't have to be that way. It's been a Debbie Downer so far. I'm going to try and show you we have solutions. If we don't make any cuts, this is all going to come to pass. But we can still fix this problem. We must stop lighting fossil carbon on fire as quickly as possible. There have been major extinctions in the past. The great dying in 252 million years ago. Volcanoes burned through are called the Siberian traps, which are huge coal fields, releasing massive amounts of carbon over 100,000 years. Because of the rapid climate change, 90% of all life perished, and it took millions of years for the dinosaurs to flourish. Everything we're seeing right now is happening 300 times faster. The 5 major geologic extinctions, the last one 65 million years ago, we are now in the midst of a 6th great extinction, but we're causing it. The dinosaurs couldn't stop the asteroid, but we can stop what is happening now. We're talking about species diversity losses, overfishing, freshwater availability, declines in soil quality, too much nitrogen, huge amounts of plastic waste, the pesticides and carcinogens, and the loss of rainforests. Here's a little perspective. The Earth is 4.5 billion years old. So let's scale that to 46 years. If it was only 46 years since the Earth developed, 8 months ago, the dinosaurs lived. Human beings have been here for 4 hours. The Industrial Revolution began 1 minute ago. And in that minute, we've increased CO2 from 280 to over 420, a 50% increase. It's the rate of carbon change that is the big concern. So what do? We can't do much in the short term to stall or reverse the warming, but we can help mitigate the impacts. Increase water storage, promote water conservation, new road construction techniques, modernize our fire and forest policies, improve public warning, change zoning and threat areas. We can do new agricultural techniques that maybe do not use as much water, smart and effective regulations. We need to find solutions. How do we energize our modern society without burning fossil carbon? I believe it's a combination of renewable energy resources and new designs in nuclear power. Solar and wind are reliable on a large enough scale. It's always sunny or windy somewhere. We need to have large-scale battery storage, and this is expanding. Great new research on iron batteries. It's water, iron, and air to make and store electricity. The most common element of the planet. It's a big ball of iron. We must improve our transmission. This is so critical. Now, as far as nuclear, I don't want to discount it because it could be a real game changer. Small modular reactors, hopefully lower production costs. We're not seeing that yet. You can look up liquid fluoride thorium or LIFTR reactors. They're much safer. In theory, no meltdown possible. That's true. But they're expensive and not currently available. And of course, the power of the stars, fusion, which would solve all the problems. But even though we're making some real breakthroughs, I think we're a couple orders of magnitude low on funding it. So the joke has always been that fusion is just 25 years away, but it would be the ultimate solution. But there are other things that are also available. Enhanced geothermal energy. There's a project called FORGE in Utah, Frontier Observatory for Research in Geothermal Energy. Using many of the same techniques developed in fracking, we can create small fissures in extremely hot rocks. These would be igneous rocks, not sedimentary. Shoot the water in there and generate high pressure steam. And you could use this in many locations all over the country. Use that to spin generators. The drilling costs will decrease and it could produce a much wider use of geothermal. And we have great resources. This is a map from NREL, again, here showing all of the resources over the western United States. Could be a huge solution. And NREL right here in Colorado, in Golden, Colorado, has an important role. They do so much great research, improving the power density of batteries, greater efficiency for solar panels, the development of something called perovskites. I'm testing it right here with one of the researchers. You can, with an ink, actually paint onto surfaces and make it into a solar panel. Imagine putting perovskite materials in house paint and using it to generate electricity, or in car paint. We can have much larger and more efficient wind turbines. Our offshore wind is a huge potential resource. Recycling the materials so that we can close the loop. And these are smart people, things we haven't even thought of yet. All right, so let's talk about carbon sequestration, because that's put out there a lot. Again, numbers don't lie. It is expensive and it requires a lot of energy. So scrubbing the carbon dioxide from a coal or gas-fired power plant requires a plant that's 30% bigger. That's not very efficient, and it is not proved scalable. We add 100 million tons of CO2 to the atmosphere every single day from the burning of fossil fuels. If we could get the price of sequestration down to $100 a ton, which right now it's not even near, that would be $10 billion a day just to remove what we put in every single day. So we put in 2.5 parts per million of CO2 every single year. Do the math. That means it would cost us $3.65 trillion every single year just to suck out what we put in. That's not even lowering it. It's incredibly hard to put the genie back in the bottle. That's why having a tax on carbon makes complete sense, because we should not be privatizing the profits of the fossil fuel industry and socializing the costs to the entire planet. It costs, carbon fuels cost $10 billion a day in what they're putting into the atmosphere. That is the price of carbon. Suddenly, it makes renewable energy and nuclear look a lot cheaper. So the best solution is to stop burning fossil fuel. Saudi Sheikh Yamani said the Stone Age didn't end for the lack of stone, and the oil age will end long before the world runs out of oil. Now, we'll still be using oil for a long time, even in California, where they will prohibit the sale of new cars that are not EVs in a decade. There'll still be plenty of used cars that run on fossil fuel. But the reason the car manufacturers know they have to electrify their fleets is because Ford and GM and Toyota and all of these manufacturers are not in the business of selling used cars. They sell new cars. And California buys 15% of all new cars. And so as California goes, so will the rest of the United States. And we will be selling primarily electric vehicles by the time you are 10 years older, my friends. And almost 100 years ago, Thomas Edison said, "I'd put my money on the sun and solar energy. What a source of power." I hope we don't have to wait until oil and coal run out before we tackle that. But folks, on to happier things. This is happening. The new energy bill that our president signed a year and a half ago is changing things. The electrification of everything has just begun. There are massive solar fields in California, and when you drive along them, they look like this. They go on and on, acres and acres of solar. This is not just in California. It's happening in many locations. And these are many high-paying jobs. There are many more jobs in renewable energy than in coal. And you can't import the wind turbines. They are made domestically because they're far too big. And change can be dramatic. This is a picture of New York City in 1900, Fifth Avenue, Easter Sunday, and inside that circle is the one car. Henry Ford came out with the Model T. 10 years later, everybody, average Americans, let me put it that way, could afford a car. That's one horse and buggy. This is going to happen. There is a company called BYD in China that is now the world's largest auto manufacturer, ahead of Tesla, because they are offering very high quality electric vehicles that get high mileage that can be priced as low as under $12,000. They're available in Europe. They're not here yet, but it's also why the American manufacturers are realizing we better get our act together and offer low-priced, affordable, dependable, high-quality electric vehicles, because otherwise we will be the next horse and buggy maker. Now, I've spoken to over 1 million children in my career at schools all over Colorado and in the other television markets that I've worked at. And those schools are filled with our future engineers, scientists, inventors, and political leaders. Lockheed Martin is our big aerospace manufacturer here in Denver. And I was out there a few years ago doing a stand-up in front of the new weather satellite, which is now in orbit around the planet. And all of these technicians were working on it. When I finished, they came over to me and said, "Mr. Nelson, could we take a picture with you?" And I said, "Sure, why?" And they said, "You totally came to our grade schools when we were little kids." And I'm thinking, wow, these people are all rocket scientists now. And maybe I played a small role in that by speaking to them about the value of math and science. And we have little kids in those schools right now that are become the next inventors that create something amazing. When John F. Kennedy was a candidate for president in 1960. He gave a speech called the New Frontiers speech. And in it, he said, "We stand today on the edge of a new frontier, a frontier of unknown opportunities and perils. It would be easier to shrink back from that new frontier, but the times demand new invention, innovation, imagination, and decision." And he went on to say, "Our problems are man made, therefore they can be solved by man. No problem of human destiny is beyond human beings. We had the will to get it done. We got to the moon in less than a decade." An amazing feat with technology that today you would have in your pocket. And I'm not talking about your cell phone. The technology in the Apollo rocket was the technology of the key fob that opens the car door. We can do this. We have done it before. Great and expensive projects have been completed in our past, and they can be again in the future. The Transcontinental Railroad in the 19th century was a tremendously expensive project that transformed our nation. Nearly 100 years ago, we tore up all of the walls and ceilings in all the buildings in major cities and put in indoor plumbing and water treatment. Very expensive. Aren't you glad we have it? The Rural Electrification Project in the 19 transformed rural America. We can transform rural America again to be the source of so much renewable energy power, wind and solar. The Manhattan Project, for good or evil, was an amazing project. The interstate highway system, NASA and Apollo, fiber optics, the internet, high-speed computing, all of these vastly expensive infrastructure projects, none of these have caused us to not modernize our society in a successful way. And we're doing it again. Renewable energy and battery technology, if you're not paying attention, they are growing and changing at amazing speed. Wind power expanding fast, huge utility scale solar fields. The costs for renewables have tumbled to the point that solar energy is a good buy for utilities, not because they're just trying to be good citizens, it's because it's cheaper. And so they're switching to wind and solar. Bus and truck fleets going cheaper because going electric because it's cheaper to maintain the fleet and to fuel the fleet. Far more efficient and much lower maintenance costs. Two of the greatest American infrastructure projects. 1862, Abraham Lincoln signs the Transcontinental Railroad Act, transforming America. And in 1956, Dwight Eisenhower signed the Interstate Highway Act, once again transforming America. Both, by the way, Republican presidents who signed this legislation because it was visionary and it was important and it was the right thing to do. The next great project that we need to transform our nation and eventually the world is the direct current supergrid, a high voltage, mainly underground electronic transmission system, the interstate highway for electricity. It would be much more efficient. There's far less line loss with direct current than alternating current. We could use the existing right-of-ways for the interstate highways and for the railroads. Cable would be buried. It would be about the size of a volleyball, buried underground, much less worry about a transmission line overhead that's not very attractive. So there's less NIMBY. You could move the energy easily from where the wind resources and the solar resources are to where the need is. In addition, this grid would be protected from a massive solar flare or from a nuclear EMP, which is an electromagnetic pulse. This would be an expensive investment, not cost investment in infrastructure, a huge job creator that if we could get it done would put all kinds of jobs into rural America to build this project. Regardless of politics, it makes America safer, cleaner, and a leader in new energy that can be a model for the world. This would safeguard us from the risks of a massive solar flare or an electromagnetic pulse that could knock our power grid offline for not days or weeks, but for months or years. As we are in an election year right now, our political leaders must know that climate change is a top priority. The physical science is simple. Add heat, it gets warmer. The political science of fixing the problem is much tougher. And far too many of our leaders are acting as if we have a pot of water on the stove that's boiling over, when in fact the house is on fire. Ladies and gentlemen, knowledge is power, but only through action. Regardless of where you stand on the political spectrum, your politicians need to know that this is the most important issue we face as citizens of this planet for the generations ahead. I'm going to finish with a couple of quotes that I particularly like, that I've found significant. And the first from Albert Einstein: the significant problems we face cannot be solved at the same level of thinking with which we created them. We need advanced thinking. We need ideas to fix this. I am not a relative of Gaylord Nelson. I am a native of Wisconsin, and he was the senator and the governor of that state. He also is the founder of Earth Day. And he importantly said, when it is asked how much it will cost to protect the environment, one more question should be asked: what will it cost our civilization if we do not? And one more from JFK: today our concern must be with the future, for the world is changing. The old ways, the old era is ending. The old ways will not do. And you look at the climate summit here, and we have all of these wonderful things: energy independence, preserving the rainforests, sustainability and green jobs, livable cities, all of those things listed. And the skeptic says, what if it's a big hoax and we create a better world for nothing? Cynical at best. These are my three grandchildren, and that is Liam, Owen, and Josephine. I do this for them. I do this for all future generations. When the Soviet cosmonaut Yuri Gagarin, the first human being in space, got to the edge of the atmosphere and looked out of his tiny porthole of his spacecraft, he was terrified. He was not afraid there was something wrong with his ship. He was terrified because he had always been taught that, as a little boy, he had been taught that he lived at the bottom of a great ocean of air. And as he looked out at the tiny film of an atmosphere that separated the Earth from the cold darkness of space, it terrified him at how fragile it was. As far as we know, out of the vastness of the universe, the planet Earth is the only place that harbors life. I think there's a lot more out there. It's just very far away. And so for right now, there is no planet B. This is our home. This is where we make our stand. And we can still fix this. It's not just about the polar bears. It's about our children and our grandchildren. We can still fix this, my friends. And these are three really good reads I would like to suggest. Again, the QR code is for my little book on climate. Please download and share. But I would highly recommend the new book from Dr. Michael Mann, Our Fragile Moment. It is fabulously written. There is a local climate writer here in the Denver area, in Boulder, Jeffrey Bennett, who has just put out a recent book called A Global Warming Primer. Very good. It's about maybe an hour-long read. And then there's an excellent book called Fire Weather, which is really compelling. It relates climate change to the wildfires up in the tar sands region of Canada a few years ago. And it is an excellent book. Ladies and gentlemen, I will be open to questions, comments, thoughts. I greatly appreciate your time. This is a subject that I am very passionate about, and I hope that I have shared a little insight into the problems we face and the fact that there are solutions that are out there. But we need leadership to get this done. And especially in America, as we have an election coming up, please understand that every vote counts, and we can work on this together. We need to have both sides of the aisle, and we have a lot of pushback from special interests, but we can still get this done. So thank you much.
That's one of the most impactful climate talks that I have seen after seeing quite a lot. I'm curious. A lot of time people are seeing the impacts of climate change. You're dealing with it every day, looking at some truly depressing and horrifying statistics of the planet. We can look at these new technologies and that's helpful, but I'm curious when dealing with all of this every day, what keeps you going? What is keeping you optimistic about the future? And what do you suggest to other people to have hope for the future?
The kids. When I go and speak at schools and there's 300 kids in the gym and they're all enthusiastic and excited, I talk mostly about weather because you can't spend an hour doing this to the kids or they won't listen that long for one thing, but they want to learn about tornadoes and lightning and all of that because that's the flashy stuff, if you will, in weather and climate. But I tell them, kids, let me talk a little bit about climate change. And there's something in the room right now called carbon dioxide. It's part of what we're breathing. There's air, and the air is oxygen and nitrogen and carbon dioxide. And the carbon dioxide acts like a blanket around us, and it traps heat. And if you have a thicker blanket on you when you go to bed at night, you stay warmer. And we're making that blanket thicker when we burn oil, coal, and gas. And so we have to stop doing that because it's causing the planet to get warmer. And then I explain a little bit more about it by saying why I'm interested and I'm excited about this. I hold this up and I say, these didn't exist 20 years ago. And when I was a kid, we didn't have anything that was close to this. And these have the power of a soup computer that used to fill an entire room. And now we just carry them around. I said, I don't know what kind of amazing inventions we're going to have in another 20 years, but I know who's going to invent them, and it's you guys. And so I want all of you to really pay attention in school and ask your teachers questions. And if you don't understand something, it's okay to raise your hand. And if you don't feel comfortable raising your hand in front of the whole class, go to your teacher later and say, I didn't quite get that. Can you explain that to me in another way? Because that will make your teacher a better teacher and it will help you understand things. And I'm excited that these kids are going to invent amazing things. I'm reading a book right now about a guy who was my college roommate who starts this research here in the Boulder area. He started it in a garage and invented things that are now on the planet Mars. And there are brilliant kids out there in the schools right now that are going to help us solve these things. So we have to give them an encouraging message of, yeah, we've got a problem, but we can fix this. And that's why I show the examples of all the things from the Transcontinental Railroad all the way to modern computing. We have solved these problems before. So don't let anybody tell you that, oh, it's just too late. It's too big of a problem. So that's what pushes me. I look at you, Gabriel. You're a young guy and you're doing this right now. And this is what's going to solve it.
Yeah. Thank you so much for that, Mike. That means a lot. I remember seeing you on the TV back when I was in Denver in school. So truly inspiring to meet again. Yeah. I want to go off of that a little bit. So a lot of what you're doing, it is simplifying and distilling down all this information about weather or climate down to just 2.5 minutes on TV to even just this book of like 10 minutes about CO2. So how do you deal with simplifying this information so the public can understand it without losing on a lot of the complexity of climate change? And also on that, what do you think is the most dangerous misconception about climate change that persists today? And how does your book address that?
Okay, there's a couple of things. The one thing is that you can't even forecast the weather tomorrow accurately. How can you know what's going to happen in 100 years? All right, again, come back to what I talked earlier. Weather is harder to predict than climate, okay? Climate is a long-term thing. So I like to say weather is one play in a football game. Climate is the history of the NFL. Global temperature is even simpler than that. Global temperature is basically the basic rules of football. 4 downs to make a first down. A touchdown is 6 points. A field goal is 3 points. That's global temperature. All global temperature is heat in versus heat out. If you trap more heat, the planet gets warmer. So all of these people that show up on a certain network in the evening and try and make this so much more complicated, it's all just frankly crap, because the fact of the matter is we know exactly what's happening. We're changing the chemistry, we're absorbing more heat, and therefore the planet's getting warmer. Don't give me all this other stuff about we've got to do this research and we've got to do that. And boy, we maybe should think about this for another 20 years. And while we're doing that, it's okay to keep burning fossil fuel because we're going to figure out how to suck it all back in. I just showed you it's $3.65 trillion a year just to stay even. The best way to sequester carbon is to not light it on fire in the first place.
Yeah, absolutely. I think it's clear that the issue is quite clear. We're seeing it right now with wildfires. I experienced one of those back when I was in Denver. Even school days canceled because of the heat. Yet it seems like still so many of our political leaders are just refusing to see that as a case. And there's a massive political divide. For instance, the Pew Research Center found that while 8 in 10 Democrats describe climate change as a major issue, and that's up from 6 in 10 a decade ago, the Republicans only 23%, so 1 in 4 actually identify it as a major threat.
Right.
So how can we bridge that understanding of climate change across party lines? Because clearly it's not a political issue.
For instance, I grew up in the 1960s. My mother was a smoker. And I remember seeing the early studies that said smoking could cause lung cancer. And then I remember seeing they had all kinds of guys in white lab coats paid for by the tobacco industries that would say things like, we've always had lung cancer long before cigarettes were invented. So how can you say for sure that lung cancer was caused by cigarettes? We knew then, but the lobby was pretty strong. Okay. My mother died of lung cancer. In the 1980s, when we had the tanning beds, and they would come on and say, it's a different type of ray. It's healthy. It's vitamin D. And my sister, who had the same complexion that I do, was very enthusiastic about tanning beds, and she died of melanoma. Those are fractions of the amount of money that the fossil fuel industry has incentive for to keep us lighting this stuff on fire. We're talking about trillions of dollars of assets that the only way they make money on it is to dig it up and burn it. And so those politicians are being paid for by the fossil fuel industry to delay. If we can just delay, regardless of our grandchildren's fate, let's just delay. And it is a terrible thing, but it's something that we'll have to fight. And we can still all fight that in this country, at least with our vote. And so hopefully we can do that. And the fact that we're having such dramatic changes in the cost of renewables and the invention that's happening in battery storage, think about this. This is not a long breakthrough. When I can hold this up and say, this used to fill a room, and now we hold it in our pocket and don't even think about the fact we have a supercomputer, there will be a day not long from now, batteries charge very fast, have a range of 700 miles, and are cheaper than internal combustion engines. Why, at that point, would anybody want to buy a car that has 90% more moving parts, that has to go drive somewhere and stop and fill it up when you could leave your garage completely with a full charge? And if you decide to travel across the country, all right, somewhere in Kansas, you stop at a supercharger for 15 minutes, get a snack, and your car's charged enough. This is all going to happen. And the fossil fuel industries are terrified of it, because when it does happen, that is going to change the world. Now, here's the thing. In the 1930s, the railroads, when the airlines were coming along, could have realized, you know what, we're not just in the railroad business, we're in the transportation business. Let's buy up all those railroads and let's run those too. In the 1980s and 90s, the newspapers could have realized something. We're in the content business. Our business model is not printing on newspaper and putting it in trucks and shipping it out 12 hours later somebody's house, when we can instantly get it to the consumer. And they said, we survived radio and we survived TV and we'll survive the internet. If the oil companies realize that they are in the energy business and embrace this, and in some cases they are, one of the biggest solar fields in California is owned by a company called Masdar, which means source in Arabic. And that solar field, it's called Big Bo, is owned, in fact, by the United Arab Emirates. Realizing that if we're going to stay in business, we got to realize we are in the energy business. And I'll circle back a bit to nuclear fusion, because we say that fusion is always 25 years in the future. Fusion is actually only 8 minutes away. We have a really big, dependable fusion reactor that is merely 8 minutes away, the sun. And if we just capture that energy and store it and transfer it where it's needed, we can do just fine. And we can do this with a relatively small amount of land in the United States and in the Sahara Desert and in China. And as the battery storage improves, this is what I think is really exciting.
And as you said, We have our Jetsons phones here proving we're creative, we can get stuff done. So let's go out and do it. Thank you, Gabriel, for taking time to join us today. One reason I reached out to you, having experienced the Marshall Fire yourself, and then going on to be in the Denver Public Schools and helping get the Students for Climate Action going. So that's another session that'll be on Thursday. They're going to talk about how they got the school district to prioritize this. So you answered your own question. How do you get those leaders to make a change? That'll be a great session to tune into as well. And up next, we have our Caring for the Ocean session with our scuba diver, Elsie Gabriel from India, and Franziska Elmer, a marine biologist who is right now in Canada, but from Switzerland, and Claudia Hurtado in Canada, who is also a marine biologist. And they're going to be talking about caring for our oceans. So thanks so much, Gabriel and Mike.
So thank you to the audience for listening. Gabriel, thank you so much. Keep up your great work. And Joan, thank you so much for organizing all of this.
Oh, yeah, it's my pleasure. All right. See you guys.
Bye-bye.
Thank you so much.
Thank you.